Thank you. It's good to be back here. For me, it's Old Home Week. I came driving across the Banana River this morning, and the skyline's changed, but lots of old memories there. Whoop. All right, what'd I do? Oh, I went the wrong way. So I used to work here for a couple years on a classified program, STS-33, and I get the mic. On STS-33, and had wonderful opportunities to explore the pad, explore both sides of the Cape, both Cape Kennedy and Cape Canaveral, and seen some changes over time. I served in Australia with the US government, and able to get out to Honeysuckle Creek and down to Woomera and some of the facilities there. So kind of understand the worldwide challenges that we all face here. My father, Bob Toth, was an aerospace engineer. Like me, he's relatively tall, and he tells the story of working at Chrysler Missile Company on the Redstones. He said at one point this little short guy comes up to him and says, "Hi, I'm Alan Shepard. I'll be going up on this thing." He said, "Nothing focuses your mind." He was responsible for man rating it. He was responsible for the standards used in all the parts and everything. He said, "Nothing focuses your mind like meeting the guy who's going up on the pointy end of that." And I consider myself fortunate working on Shuttle Discovery with a wonderful crew of astronauts, a broader crew of engineers and technicians. We had Fred Gregory, John Blaha, Story Musgrave, Kathy Thornton, and the late Sonny Carter on our crew. But my father's and my flight vehicles are now at the Udvar-Hudson out in Smithsonian. My father's passed away, and I guess that makes me a museum piece. Since then, since I retired from the government, I've gone to work on preserving cultural heritage, working with digital assets and how we can digitize to better preserve some of the, and to see some of what we can't see with the human eye. We borrow from aerospace with our technology, just as the Webb Space Telescope works in bands of light we cannot see. We work, as the Webb and the Hubble, more so the Hubble, we work in imaging from the UV through the visible and into the infrared. With optical, we've also worked, and I'll touch briefly on some X-ray analysis, but I work at the Stanford synchrotron using it to map, do elemental maps, primarily of documents. Our multispectral imaging, we use a large, for those of you technically oriented, large camera, 100 megapixel or 150 megapixel. We use narrowband imaging instead of having filters where it's going to throw your registration of each of the pictures off. We use lights, LED lights, tuned LEDs, starting at 365 nanometers and working up to the near infrared into 940 nanometers. The camera is achromatic. It's a black and white camera. So we have no bare array. We have no filters that are going to interfere with the light that's reflected and fluoresced onto the sensor. We do use filters to block the reflected light sometimes to capture fluoresced. All of which is a bunch of technobabble. Let's get down to the real work. So what we do is we'll take a series of images, perhaps 25 images in different, I'll say, colors of light, different wavelengths, different spectra, and we will then put those together, and then we'll statistically process them. We've mainly been working with manuscripts, worked on the earliest copy of Archimedes, early biblical texts, all sorts of Gettysburg Address, that type of thing. And some of it, we then do processing to try to bring out information that's otherwise not seen. In this case, I love this project. This is Holy Trinity Parish in New Orleans. After Hurricane Katrina had flooded their basement and flooded their sacramental records. Unfortunately, they got left there for about 5 years. And you can see mold and mildew, which will actually just digest the ink and paper, as well as parchment when we dealt with that. So leaving not much to work with, but they were trying to recover from some information. So we would capture images and then we could digitally process them, and we could get, they were pleased that we did get more text here. Now some of it becomes blobology because of the, not to use a technical term, but because of the wicking of the ink into the paper fibers. So that became, that's a challenge we couldn't deal with in terms of the statistical processing of this stack of images to try to then bring out those results that offered the best visual perspective. That becomes more a matter of artificial intelligence or other processing. So also fire, this is the, unfortunately, the Anomalia Library in Weimar, Germany. They suffered a terrible fire in 2004 up in the attic, just before they were going to move into a fireproof structure underneath the square there. While the firemen were fighting the fire in the attic, the townspeople had a chain taking all the books and manuscripts out from downstairs there. So upstairs were a bunch of musical scores like this. We were able to recover, you can see a bit, it's hard on the small screen, but we were able to recover in the charred areas, or in the scorched areas, I should say, where it's charred. You know, you're not going to get much there, but in the scorched areas we could get more. Hard to see here. I mentioned we worked on the Gettysburg Address drafts at the Library of Congress. They have two, the Nicolai and the Hay draft. The Nicolai, which is this one here, is folded into thirds as if it was, and it's handwritten in Lincoln's hand, as if it was folded up to go into someone's pocket en route to a cemetery up in Pennsylvania there. And so we were analyzing, trying to look at the different inks and, well, actually it's the same ink, but the pressure of Abraham Lincoln and some of his annotations. Sometimes we can get more information. This is first edition of Harry Potter, which I also like to point out. This is not magic. This is science. This is empirical information and data. We're not tweaking it with Photoshop to try to say, oh, this is best. We're trying to get the best statistical results that offer information that is useful. So, and you can see some changes. This is pencil here in some annotation. I think there's an added comma here in the Gettysburg. But what was interesting to us is, as you can see, the first page is on Executive Mansion stationery. Second page is on just torn foolscap paper. And where it says, a government of the people, by the people, for the people shall not perish from the earth, just blank down here. Well, I was standing there, you know, it's just amazing to be looking at this close up, not to mention it's in English, and I was usually dealing with early Greek or Syriac, which I can't read. So, so I was looking at this, and as the UV light came on, down at the bottom here, I saw a glow. And I said, hey, we got to look at this. There's something going on here. So we looked, and it's hard to see in this image, but you can see there was a thumbprint there. And then we said, got to do the back, and there's 3 fingerprints there, as if someone was holding that piece of paper perhaps to read. There's enough loops and whirls to do an analysis, but there wasn't an FBI fingerprint lab back during Civil War times, so there's nothing to do a comparison with. So whether it's a conservator, doubtful these days, but who knows back when, or Abraham Lincoln, we don't know. But that was, you know, it's the type of thing that shows up in the different wavelengths we don't see. As I said, we do work with documents. We were working with a Gutenberg Bible and Korean manuscripts, or documents, printed documents. We Westerners learned that, of course, Gutenberg Bible, earliest, first movable metal type. Well, there's Korean manuscripts that used it first. So we took these out to the Udvar-Hudzi facility, and we were with the FRIR. We were collaborating with the FRIR on that, and using the microscopy tools that they have out there. So, but I just loved it, having the Star Trek model in the background of this early Korean document. So bringing this to space program, when we completed our launch of STS-33, this is the page for the launch instructions. You know, fire up main 3, main 2, main 1, and then fire the solids, the SRBs. So a bunch of the Air Force team had signed this page, and then they made copies of this. And then I had a copy of this, and I had friends, and then ultimately the astronauts sign it. But some of the modern inks are fungible and faded away. There's signatures here you can't see. So with the multispectral imaging, we were able to bring out, you know, Bob Padishaw, Stu H. Let's see, there's anyway, a number of these signatures that you can see better with the multispectral. So Tim Zeidel, Wayne Owens, and some of the others. So Kathy Thornton here. So the use of the multispectral allows us to better understand, one, which inks are real and which are reproductions, and also just better see the names that are there. Ran into this, I work with private collectors too, in addition to institutions around the world. And one of the private collectors collects Robbins medallions, and I will explain further on that. Well, he has a PPK list, the personal preference kit, I guess it is, from Gene Cernan, which he has to help establish the provenance of his Robbins medallion, that it was flown. And so he did you can see Gene Cernan had censored out some of the other objects in his PPK. So we used the multispectral imaging to go through and image this. And you can see sometimes the undertext pops out. Now, I was surprised because I expected the infrared to penetrate the over ink and we would have the under ink. Instead, it was the other way around, that in the infrared, the original ink faded away and the Sharpie or whatever was used by Gene Cernan is there. But it's modern paper. Modern paper fluoresces. It has brighteners in it. So with the ultraviolet, it caused that fluorescence that in effect gave us a transmittive light coming up through that overtext or that censorship, and we were able to then see, and it's very innocuous list, including his wedding ring and whatever. So we could bring out that information which he had tried to cover. So lesson for everyone, if you're trying to cover something up, go ahead and black it out and then make a photocopy of that. So, so anyway, we were able to get more information which helped establish provenance. Photos to better reveal information in photos. This is from Jefferson County Museum in West Virginia. And this is one of the many Gene, drawing a blank, pardon? Yeah, Gene Kranz. One of his many photos with failure is not an option, which of course he never said, but was said in the movie, and so he kind of adopted it. But so we took, this is what a stack of the multispectral images will look like. They're all registered, and you can see how we go from, you can see the different spectral responses as we get into, especially into the infrared where it just totally disappears. That's one of the infrareds, for example. But you're able to characterize the ink better, whether it's used for authentication or whatever, you can get different spectral responses from the ink. One of the things I've had opportunity to work with is the lunar visor worn by John Young on Apollo 16. Near and dear to my heart because I grew up in Orlando and John Young's an Orlando boy. And I remember whichever Gemini mission he was on, there was a big deal with a Gemini floating in Lake Eola and helicopters flying in and stuff like that. So it's pretty cool as a kid. So this is now in a private collection as the owner's representative. And we had opportunity just to characterize both the helmet and what we could do with multispectral imaging. And so it's got the data plate and all that stuff on it if you want the details. So we did the multispectral imaging. these images are showing the different colors of light. Of course, we're working with an achromatic camera, so the images we collect are black and white. And so then we would process those images. We ended up with lots of data. We collect 25 images. Each image is 192 megabytes. So we end up with lots of data. Happy to share these data too. I mean, we're talking about some type of of preservation and access, and especially from private collections. We've talked about private collectors. This guy and some others I know are eager to share the information, and I think in some cases actually do a very good job. The Archimedes palimpsest, Sirac Galen palimpsest, they made the data all freely available. And as a result, others have latched on and started doing research independently. So it's not mediated, it's just out there in flat files, and helps preserve it too. Anyway, so able to do the processing, we use ImageJ, which is a National Institutes of Health developed statistical algorithm. And you can see some of the differences here between the beta cloth, the fiberglass. This is the gold visor, or it looks gold. And these are artifacts. These are the reflections, the lights. So you have to pay attention to, especially with 3D objects. We do a lot of 2D, and it's pretty straightforward to calibrate 2D. 3D, you get all sorts of artifacts from the reflections. You have to be careful of that. The Velcro responds in one way. The beta cloth in another way, whether there's moon dust on this. He did wear this on the lunar surface. And then the stitching, yet a different spectral response. The stitching on the Velcro in here, but less so here. So opportunity to be able to characterize the different materials, as well as in some cases for conservation, identify residues and areas that could be endangered. It has a signature on it. So able to characterize the signature and also some of the wear and various other points there. While I had X-ray, a Bruker XRF, X-ray fluorescence analyzer, went ahead and put it over the analyzer to analyze the visor material itself. I worked with X-ray synchrotrons. And yes, it's not a good idea to always, my hand's actually a little off to the side here. This is very, very low powered, but you don't want to regularly be holding it like that. It was just easier the way we had the setup there. So health and safety, please don't pay attention here. But this is the type of thing you get. So, and the thought here is you can, and we've done this with XRF mapping, you can characterize the elemental response and say, here's iron, here's gold, here's copper, here's whatever. And then for these various points, and use the multispectral imaging where you don't need an X-ray synchrotron or a Bruker to then extrapolate from that and say, I'm getting this spectral response from the iron, say, in a manuscript, or I'm getting this spectral response from whatever it may be. So this highlighted, you can ignore the rubidium because it's a rubidium bar that's generating the X-rays. So that spike is incorrect. But you got the gold, the copper, and various other elements there. So the main reason we were doing X-ray fluorescence was for a collection of Robbins medallions. And so we were trying to analyze the components of them. So here's a Gemini medallion. These medallions were flown. Usually they printed up a bunch of silver ones, and they'd print a few. First it started with 2 or 3 gold ones for the flight crew, and then their wives wanted them, so they'd do 6 of them. So, so this is Gorda Cooper's from Gemini 5, and this is primarily silver with gold and copper trace. So pretty much sterling silver. So the question was, Apollo 1 and their Robbins medallions, which were in the transition from Gemini to the Apollo program, what were they made of? Now I know this, especially from the back, this says Apollo 11, but this is an Apollo 1 medallion that was flown on Apollo 11. They took it with them, the astronauts took it with them. So we analyzed that, and we got found that it was primarily gold with silver, copper, and zinc, which followed the same pattern as the Apollo. So it was not really of the model of the Gemini, which is just cited as gilt. In fact, this is just cited as gilt. So that's why the question was, what does this comprise? Now we can use the multispectral for other things. This is Harrison Schmidt's food bag. And here again, you have to think about what you're looking at. You're looking at a 3D object here. So you're getting, this is reflection. So this does not offer a spectral response, but it's got this authentication thing on it. It's got his signature on it, that type of thing. So coming back from space all the way back to Civil War again, I have to give thanks to Jason and the NCPTT, because I live near the city of Fairfax, outside of Washington, D.C. And the city of Fairfax owns this home called Historic Blenheim. It was used as a hospital during the Civil War, and civil and Union soldiers lived there. The house had been newly built in 1865, bare plaster on the walls. Soldiers there, lots of time, very bored, they left graffiti all over the walls. The only way to study that graffiti, as Andrea Lowenwater is doing here, was to sit there and look at it very closely. So with a grant from NCPTT, a very, very small grant, actually it's 20K, I thought it was 25K. At lunch I said 25 million, I thought no, that was the different part of government I worked for, 20K. So we got a grant from NCPTT to look at multispectral imaging these walls to support conservation and to get more information. The thought was, a lot of these walls have been covered with more modern wallpaper. Could we see through that wallpaper? So, so we set up, and the first thing we had to do is, with all of these images, we are very careful about the metadata for the images to make sure that we can understand, and future generations can understand this. I've been harping on it from the back, that these data will be preserved and be accessible by future generations. So we had to be able to identify what walls are they, and it didn't follow the prime compass points. So we designed the walls with, as you come in the historic entrance, A's on your left, B's in front of you, C's to the right, D's behind you. And part of this was to set up a process that could be used by any institution or even a small under-resourced organization. And then say, okay, and then each room, each wall had started 1 through 5, and then we had a whole metadata schema for that. Attic, same thing. So we'd identify key areas. We couldn't do the whole house for 20K. Schlepped the gear in there and unpacked it, set it up. We work in the dark, so we put aluminum foil over the windows. This is the business end. There's the camera. There's the filter wheel in front of it. There happens to be a red filter there. There's the lights. It runs from a laptop. So we got all these, we'd get stacks of images, and we'd process them. This is in the attic where there's some water damage, so we could bring out more the residue from the calcium and other things that you conservators can better say is going on there. But we could also, there's a little drawing up here, and we could bring that drawing out better. These are all carbon, primarily there's some wax crayon, but it was either charcoal or graphite. So it could bring out more information. And when we present the data, or make the data available, we always include a README file with it. And George Mason University, just out of Hyde, set up using Omeka an access portal for it. Building on that, we got an NEH grant, National Endowment for Humanities, to just digitize, to set up a project of digitizing the walls, and we now are bidding on a bigger grant. Just to the west of us here, Walt Disney said, it takes people to make dreams come true. And I've been fortunate, worked with some great people, wonderful to meet and to be working with great people here. And I think we always tend to focus on the work processes, we focus on the technology, but we really need to focus on the people and how to be able to share and to use these information. So, thank you very much.